Hi, I am Sheikh Mahbub Basha. Welcome to my channel. Happy Learning.
Hi students, welcome. In the previous classes, we have discussed about evaporation, applications of evaporation in our daily life. Then we had a demonstration about evaporation is a cooling process and the factors affecting the evaporation are discussed and also verified with a activity. Today we will discuss about melting and boiling. Melting and boiling. So before we go deep into this definitions and all, let us start with an activity. Take a beaker, add some ice cubes, put a thermometer into the beaker. Remember, you have to choose a thermometer which can read negative temperature, that means less than 0 degrees Celsius, and also above 100 degrees Celsius. That means it should have the range from minus 10 degrees Celsius up to plus 110 degrees Celsius. Okay. So this beaker with ice cubes and a thermometer is now taken and placed on a tripod stand. Initially, note down the temperature. Temperature of the ice is noted. It may be 0 degrees Celsius. Not necessary that all the times ice temperature is 0 degrees Celsius. Ice can be at a temperature less than 0 degrees Celsius. For now, assume that the ice you have taken has the temperature minus 10 degrees Celsius. Okay. So initial temperature of the ice is minus 10 degrees Celsius. Now this beaker is kept on a tripod and start heating this beaker with the help of a Bunsen burner. If you don't have Bunsen burner, you can use any other alternative like induction coil or a LPG gas stove, etc. Right. Now, when you start heating, obviously you expect a change in temperature. So observe the readings of a thermometer time to time. For example, note down the temperature of ice with the help of thermometer for every half minute. So the temperature, which is initially minus 10 degrees Celsius, slowly increases. Minus 10 becomes minus 9, minus 8, minus 6, minus 5, minus 4, minus 3, like that. It reaches to 0 degrees Celsius. Right. So minus 10 to 0, temperature is increased because it is negative value. You know that. So minus 10 to 0 degrees Celsius, temperature is increased because you have supplied heat energy to this ice cubes. Though the temperature has reached 0 degrees Celsius, you can see the ice remains ice. Okay. You continue heating and now you observe carefully. The temperature in the thermometer remains 0 degrees Celsius. Though you have continued heating, the temperature now remains constant, half minute, 1 minute, 1.5 minute, 2 minutes, like that. Then where does this heat goes? Now when the temperature has reached 0 degrees Celsius, the heat supplied is now utilized for conversion of solid into liquid. Ice is solid form of water and water is the liquid form. Okay. So this ice now starts melting and becoming water. So solid phase is now started converting into liquid phase. All of you know there are three phases of matter: solid, liquid, gas. Plasma is there. For now you ignore that. So the solid phase is started converting into liquid phase. Okay. Here at 0 degrees Celsius temperature, the temperature remained constant, but the heat given is utilized for some other purpose, that is change of phase. Suppose within few minutes, suppose for example after 5 minutes, this water, this ice has completely melted and became water, and still the temperature is 0 degrees Celsius. That means initially the temperature has raised from -10 to 0 degrees Celsius. After reaching 0 degrees Celsius, the temperature is constant, heat supply is continued. The temperature is constant, and instead of increasing temperature, here the phase change started. The solid form is now converted into liquid form. That process is over, completed. That means all the ice you have taken is completely converted into liquid form. Now the temperature of the water starts rising. After complete conversion of ice into water, now the temperature of water starts increasing. You continue heating, the temperature of water increases 5, 10, 15, 20, like that. It increases and reaches 100 degrees Celsius. Note down time to time, every 1 minute, every half minute, note down the temperature of the material in the beaker. When it is ice, note down as ice. When it is water, note down as water. The temperature of water started increasing from 0 degrees Celsius and reached a maximum 100 degrees Celsius. Now at 100 degrees Celsius, though you are continuously giving heat, now this heat energy is utilized for conversion of phase. There it was conversion from solid to liquid. Now this conversion is from liquid to gas. Here the temperature remains 100 degrees Celsius for a while, and this water starts converting into gas. Boiling started, bubbles started, gas is coming out of this water and escaping into the atmosphere. Okay. So this water is now converting into gaseous form. Here the heat energy given is utilized for change of phase instead of raising temperature. Once the water is completely converted into vapor, into steam, into gas, at normal conditions we can't hold that gas. It is escaping and mixing with the atmosphere. If the suitable equipment and conditions are available, if we do the experiment with necessary care, we will notice that this complete water is converted into gas, vapor, and its temperature will remain 100 degrees Celsius till this complete water converts into steam. Once water is exhausted, there is no water, complete water is converted into gas, that we call as vapor, steam, etc. Now, as we have continued supplying heat, this temperature of this steam starts increasing. The temperature of the steam now becomes 101, 102, 103, like that. Its temperature increases. Suppose, assume we have suitable equipment and we are noting that values also. So the temperature increases, and assume that, take it granted, and temperature has reached 110 degrees Celsius. Okay. Now complete picture once. We have started with the ice at -10 degrees Celsius. Heating is continued. There is no stop, non-stop heat supply is there. Initially, the temperature was -10, raised to 0 degrees Celsius. There, a halt for some time, temperature taken halt, conversion of phase taken place. When complete ice is converted into water, now the rise of temperature started and reached 100 degrees Celsius. There, temperature once again taken halt, constant temperature. Instead of rising temperature here, change of phase taken place. Here, liquid to gas conversion taken place. There, after complete conversion of water into gas, again temperature increases started. Okay, from -10 to 110 at 0 degrees Celsius and at 100 degrees Celsius, for some time the temperature remained constant. Here, the ice has converted into water. Here, the water has converted into vapor gas. So now let us define melting and let us define boiling. The process of conversion of a solid completely into liquid at constant temperature is called melting. The process of conversion of a solid completely into liquid at a constant temperature is called melting. So, ice melted at 0 degrees Celsius. This temperature, this constant temperature where this conversion from solid to liquid has taken place is called melting point. For ice, this melting point is 0 degrees Celsius. Instead of ice water, if you take benzene, if you take chloroform, if you take acetic acid, like that, depending on the material you have taken, you will get different melting points. So we have done the experiment with water. For water, melting point is 0 degrees Celsius. Now coming to boiling. The process of conversion of a liquid completely into gas at constant temperature is called boiling. The process of conversion of a liquid completely into gas at a constant temperature is called boiling. And the temperature at which this conversion taking place is called the boiling point. So boiling point means it refers to a temperature. In case of water, the boiling point is 100 degrees Celsius. At 100 degrees Celsius, water started converting into vapor. So the liquid form of water is started converting into gas form, that is vapor, at 100 degrees Celsius. Therefore, boiling point of water is 100 degrees Celsius. Right. Now, let us draw this diagram. Draw a graph taking time on x-axis, time on x-axis, temperature on y-axis, time on x-axis, temperature on y-axis. Note down the all values just now we have noted in this graph. You will get a graph like this. At the beginning, it has some slope. Later, for some time, it is flat parallel to x-axis. Again, this graph has some positive slope. Later, it has got some flat. And then again, it has some positive slope. So, the initial positive slope part indicates rise of temperature from -10 degrees Celsius up to 0 degrees Celsius. This flat parallel to horizontal part represents the phase change conversion of solid into liquid where the temperature is 0 degrees Celsius. And then this positive slope part represents rise of temperature from 0 degrees Celsius up to 100 degrees Celsius. Then this flat part, that means parallel to the x-axis part, represents the conversion of liquid to gas. Then this last positive slope part represents the increase in temperature of steam. So in this graph, these two flat parts are special for us. Here temperature is constant. At this point the temperature is 0. At this point this temperature is 100. This 0 is the melting point. This 100 is the boiling point in case of water. The same experiment can be done with other liquids. We generally use water because it is easily and freely available everywhere. Okay. So this graph you have drawn is called a phase diagram. Okay. Right. So let us move to what happens while melting and boiling to the structure of this material. First, let us take the case of melting of ice. Here, the heat energy is taken and utilized for weakening the bondings between the molecules. After weakening, the bonds are break and the solid form now becomes a liquid form. Now in the liquid, the molecules are free to move. In the solid, the molecules are like the students are sitting in the classroom, whereas in liquid form, the molecules are comparable to the students moving in the premises of school during break. So, like students in the class are packed 3 per bench or sitting in a particular order. Similarly, in ice, water molecules are packed with certain design. While melting, heat energy is taken, these bondings are weakened and finally break, and then the water molecules becomes free and starts moving randomly. So heat energy during melting is utilized for weakening the bonds instead of increasing the temperature. So this heat energy taken during melting is not showing the rise of temperature. So we say that this heat is stored secretly, hiddenly, and we name it as a latent heat. The heat energy stored secretly, hiddenly is called latent heat. And now let us give a good, valid definition for latent heat. Latent heat is the amount of heat energy required to convert unit mass of a material from one phase to the other phase at a constant temperature. Here I am not saying 1 gram or 1 kg, simply I said unit mass so that it is suitable for a CJ system or a SI system. Similarly, I am not saying whether conversion from solid to liquid or liquid to gas. Generally I said from one phase to the other phase. This is a general form of definition. The amount of heat energy required to change unit mass of a substance from one phase to the other phase at constant temperature is called latent heat. This latent heat is now of 2 types. At the time of melting, it is latent heat of fusion, and at the time of boiling, it is called latent heat of vaporization. Let us express this latent heat with some mathematical formula. Suppose you have a substance of mass m and q units of energy is given. Q units of energy is given to convert it from one phase to the other phase. For m units of mass, you need q units of heat energy. Then for 1 unit of mass, you need q by m. You need q by m. For m units of mass, you need q units of heat. For 1 unit of mass, you need q by m units of heat energy. And this is called as latent heat. And latent heat is represented by the letter capital L. Latent heat is represented by the letter capital L. Therefore, capital L is equal to Q by M. L is equal to Q by M. So, capital L is the symbol used for latent heat. Capital Q is the symbol used for heat energy. Small m is the mass. So, finally you got the formula L equal to Q by M. From this, you can write the unit for latent heat. If it is SI system, heat energy is measured in joules and mass is measured in kilograms. Therefore, SI unit of latent heat will be joule by kilogram. Joule by kilogram. If it is CGS system, in CGS system, heat energy Q is measured in calories. Mass M is measured in grams. Therefore, unit for a CGS unit for a latent heat will be calorie per gram. CGS unit for latent heat will be calorie per gram. So, L equal to Q by M. If you do cross multiplication, you can write Q equal to ml. Q equal to ml. Highlight this. Q equal to ml. This is one of the most popular formula in numerical problems. Note on this. Q equal to ml. Here Q is the heat energy, M is the mass of the substance, L is the latent heat. Let us define the latent heat of fusion in CGS units. The amount of heat energy required to convert 1 gram of solid completely into liquid at a constant temperature is called latent heat of fusion. I repeat, the quantity of heat energy required to convert 1 gram of solid completely into liquid at a constant temperature is called latent heat of fusion. And as an example, for ice, this latent heat of fusion is 80 calorie per gram. The latent heat of fusion of ice is 80 calorie per gram. Let me define latent heat of vaporization in CGS units. The amount of heat energy required to convert 1 gram of liquid completely into gas at a constant temperature is called latent heat of vaporization. I repeat, the quantity of heat required to convert 1 gram of liquid completely into gas at a constant temperature is called latent heat of vaporization. And for water, this latent heat of vaporization is 540 calorie per gram. So we have defined the latent heat of fusion. And for ice, its value is 80 calorie per gram, and we have defined the latent heat of vaporization. And as an example, for water, its value is 540 calorie per gram. So all of you remember latent heat of fusion of ice, latent heat of fusion of water, and this expression Q equal to ml, where Q equal to heat energy, m is mass, and L is latent heat. We'll solve some numerical problems based on these formulas. Thank you.